In this video, we will discuss about the relationship between the zeros and coefficients of a quadratic polynomial. Now suppose if we have alpha and beta to be the zeros of a quadratic polynomial, p of x is equal to ax square plus bx plus c. Here a is the coefficient of x square, b is the coefficient of x, and c is the constant term. As this is a quadratic polynomial, then this a should not equal to 0. Now what we have is the sum of the zeros, that is alpha plus beta, is equal to minus b of a. What is b? B is the coefficient of x. And what is a? It is the coefficient of x squared. We also have the product of zeros, that is alpha into beta is equal to c by a. What is c? C is the constant term and a is the coefficient of x squared. Let us do one example. Let us find out the zeros of 2x squared plus x minus 10, and we will verify the relationship between the zeros and the coefficients. Let us name the given polynomial as p of x. Now, if we compare this p of x with the standard equation, with the standard polynomial, we have a is equal to 2, b is equal to 1, and c is equal to minus of 10. Now, p of x is equal to 2x squared plus x minus 10. We will find out the zeros of this polynomial by splitting the middle term. Our middle term here is plus of x. Here we should have 1. Let me not write 1. And complete the polynomial first. Let us fill up the gap here. Here we are going to find out two numbers where if we add or if we subtract the two numbers, we should get 1. But if we multiply the two numbers, we should get 2 into 10, which is 20. Now what if I take 5 and 4? If I subtract 5, 5 minus 4 is 1. But if I multiply 5 into 4, I am getting 20. Let me separate. Plus 5 into x minus 4 into x minus 10. We will take common from these two terms and a common from these two terms. Let me take x in common from these two terms. Then I'm going to have x into 2x, it makes 2x squared. Now x into plus 5, it makes 5 of x. For simplicity, let me write 2x plus 5. And we will find out the gap here. Now what if I take minus of 2? If I take minus of 2, minus 2 into 2x, it gives me minus 4 of x. Minus 2 into plus 5, I get minus of 10. Now another two terms. If I take 2x plus 5 in common, then from here I am left with x, and from here I am left with minus of 2. Now if p of x is equal to 0, that is p of x is 2x plus 5 x minus 2 equal to 0. This is a product of two terms. If either one of these terms is equal to 0, then their product is equal to 0. That is either 2x plus 5 is equal to 0 or x minus 2 is equal to 0. From here we get the first root, which is minus 5 by 2. And from here we get the second root, which is 2. Next, we will verify the relationship between the zeros and the coefficients. Let me name the first root as alpha and the second root as beta. Now, alpha plus beta, which is minus 5 by 2 plus 2, I am getting minus 1 by 2. And what is minus b by a? What is minus b by a? Our b is 1 minus minus of 1 by a. What is our a? Our a is 2. So, alpha plus beta, which is the sum of the zeros, is equal to minus b by a. This one is verified. And the next one, let me find out alpha into beta, which is the product of the zeros, minus 5 by 2. I multiply with 2. Then I get minus 5. And what is c by a? C is the constant term, that is minus of 10. And what is a? Our a is 2. What do we get? We get minus 5. Hence, alpha into beta is equal to c by a. Hence, the product of the zeros is also verified.